Hey everyone, welcome to this episode. Here we're going to be adding the fading function to our dialogue, specifically to our text architect, so that way we can make text smoothly come in on screen instead of the typewriter. Typewriter's good, but I like the look of fade better, which is why I included it in the system. But it all depends on your taste and what you're going for your novel. So let's open up our text architect script and add that functionality. We've already got the fade enumeration type here, and we've already got the prepare and building functions set up and configured within the prepare and the building coroutine and function. So all that's set up, and all we have to do is populate the data within these functions. So let's start with preparation. In order for us to make sure that we're ready to start building the text in this fade manner, what's it going to do? When we actually start building it, it's basically going to start where it needs to pick up at, whether we have pretext or not, and make every character that needs to be built invisible. Not hidden, but it needs to have the alpha invisible so that way it can smoothly fade in. So we need to make sure that we set anything that is our target text to be invisible, while anything that is pre-existing needs to be fully visible. And the way that we're going to get that value, that number that's going to let us know what's pretext and what's not, that's going to be the pretext length that we configured earlier. We're going to set it up here. So the first thing we need to do is we need to see if there's any pretext. Let's start off by saying tmpro.text equals pretext. If there's anything, then we're going to go ahead and make that the very start. Then we're going to check if it's not empty. If pretext is not equal to an empty string, that means we have pretext. So we want to force our mesh to update so that way we can generate the new text info and then cache our pretext length to equal the character count. Otherwise, if there's no pretext, then we want to set pretext length to be 0. And then all we need to do is make tmpro.text add the target text to itself. So at this point we've got the whole string and we've also got the pretext and the pretext length. So let's go ahead and make sure that every character in here is fully visible. If we were to switch over from typewriter, typewriter is setting the max visible characters to the total number of characters within that line. Well, if we fade something that has more text than the previous line did, and we're switching from typewriter to fading, then we could potentially be limited by what the max limit that was set earlier. So we want to make sure that we set that to a different value here, and fading is not going to use max visible characters, so we'll just set that to int max value. That way there's no limit. Ooh, help if I put an equal sign there. And once more, let's go ahead and force the mesh to update, so now it's got the target text information as well. And now let's store the text information, because we're going to reference that to get the vertices of all these characters, so that way we can fade the color on each vertex and give it a nice sweeping fade effect. Okay, so how this works is when TextMesh Pro generates the text on screen, it's actually generating a mesh for each character. And so all the meshes, they're going to have 4 vertices, 1 for each corner. And each vertice is also going to have a color applied to it. So you could have gradients on your text or anything else. But in this case, what we want to do is we want to access those vertices, and we just want to start bringing up the alpha value from 0 to fully opaque, so it fades in completely. But what we're going to need to do is we're going to need to store 2 colors for this. We want a color for the text that's going to be hidden, and a color for the text that's going to be fully visible. So let's go ahead and set that right here. We'll make a color visible color, and that's going to be a new color. And what we're going to do is we're just going to take the color that's assigned to the text component, but just make sure the alpha is set to 1. And we'll do the same thing for the hidden color. but make sure that the alpha is set to 0 in this case. That way we don't have to keep creating new colors for each vertex, we'll just store them there and reference them for each character. So now that we got our colors set up, the next thing we need to do is we need to get an array of the colors that are spread across all the characters in this string that we have. And fortunately, TextMesh Pro, in the way that characters are rendered, every character with their vertices, they have their own colors. And all these colors are part of a large array, which TextMesh generates anytime we force mesh update, like we did twice up there. So it'll generate this color array, and by manipulating that, we can change the color of each character and each vertice on those characters. So this is actually an array of color 32, which does not use your normal float values, 0 to 1. Instead, it uses bytes, which would be ranging from 0 to 255. So let's make an array for color 32 variables, and we'll call this our vertex colors. And this is going to be found inside of our text info, under the mesh info, what's been generated, and let's grab the text info.character info, the very first one. Let's get the material that is referenced off of that character, because all the text in this line is really going to be using the same material, so no need for us to waste performance just grabbing a bunch of the same materials for each character. So let's grab it from the very head of the line, and this will have all of the colors spread across. So this is where we'll be changing our characters from visible and hidden. But now let's go through and iterate through every character in this list and make sure that they have the appropriate colors assigned to them. Okay, cool. So we're looping through, and now let's snag the information for the current character that we're on. We'll grab this. Oh, if I could stop hitting the arrow key. We'll grab this under character info. We're going to set that to the text info.character info at the index we're at right now. So that gets us our character. And so now all we need to do is evaluate if this is inside of the pretext or if it's a target that we're trying to build. And we'll reference that through the pretext length. So all we need to do is check if the index that we're currently on is less than our pretext length, then we need to assign this color. But we need to do that for each vertice. So let's run a for loop with an integer called v for vertex, set that to equal 0. And while vertex is less than 4, so we get all 4 corners, we're going to increment, and what we do with this is access our vertex colors array, then access the character info vertex index, which will get us the right starting position in that array, and then increment by our vertex count here. And since this is inside of pretext, we're going to set that to color visible. And we'll do the same thing under else, meaning anything that is a target that needs to be built, we're going to set that to color hidden. Alright, there we go. So we are effectively iterating through every character and setting their color, their starting color, to either hidden or visible based on if it's pretext or not. But there's one more thing that we need to do before this actually takes effect, and we need to update the vertex data. Right now, all we're doing is editing an array, and that's not actually going to change anything on text. So we need to tell TextMesh Pro to update what we've just been changing. So we can do that through tmpro.updateVertexData. And we need to pass in a flag telling it what to update. In this case, it's the color 32 array. So we'll specify tmp vertex data update flags dot color 32. But there is an issue here. At surface level, this looks fine, but if you actually run this through play mode, what you would have is an issue where the first character inside of a string never seems to have the right color. It'll more than likely be the default color that's assigned, so it would be white instead of, like, say, if you were trying to make everything transparent, you would have that one starting character that just refuses to obey, even though you got the right logic here. And what's happening is if you have spaces or any type of invisible character inside of your string, then once we get to that and we try to access the character info and try to access the vertex index of that character, if it's an invisible character, then its index is actually going to be represented as 0. It's strange, so any spaces would actually look back towards the very first character in the line, which is why if we ran it like this, we would have that one starting character that is always visible, even when we're trying to make it not be. So the way we can get around that is we just need to check if the character that we're on is visible, and if it's not, then we just skip it. So we'll say if not, char info dot is visible. If it's not visible, let's continue on to the next item. And now we're safe. Ooh, except for the fact that I forgot to add else right there. That would have not been good. And so we could jump into our testing script and change the build method to fade here and just see what we've got going so far. So inside of Unity, any new text is going to be made invisible. So if we press the space bar here, you can see it generated text here, but it's not visible at the moment. Now, if we go to press the A key, which is for appending, then what we'll have is we get more text appended to that, but now we're seeing what was initially there. So this is officially the pretext, and the target text, the rest of that line, is invisible and needs to be built. So it's working correctly. Now let's go ahead and finish it. Back in our text architect, let's come down to our build fade function and remove this useless line now. So this is going to loop through basically every character that's invisible and start fading it in. But we don't want to do every character at once, because that would just fade the whole line in at once when really we're trying to do character by character. But at the same time, we don't want to just fade in one character and then move to the next and the next and the next. Instead, what we want to do is we want to define a range of characters that are going to be fading in at this particular time, and then remove characters from that range as they finish and add new characters to that range as it draws to a point where the next one is now suitable to start fading in. Like, if we have the last character that we're currently fading in, it reaches a certain alpha value to where it's slightly visible, now we can start bringing in the next one. So we want to kind of layer characters on top of each other gradually and fade them in that way. And the way we can do this is we can specify an integer which defines the starting point of that range and one that defines the end of that. So let's make an integer called minRange and set that to equal our pretext length. So we're going to start at the target text. And then let's make one for maxRange. And this one's going to equal the minRange plus 1, so we start just working with one character. And now to make it where the last character in this range, once it reaches a certain alpha value, the next one will come in, we need to define that alpha value. So what's the threshold? At what point do we say this character is faded in enough, let's start bringing in the next one? First off, remember that as we're working with color 32s, this is going to be a byte, so we'll specify this as a byte and call it the alpha threshold, and just set that to equal a very low value like 15. On a scale of 0 to 255, 15 is pretty low, but it'll still be enough. And I found that that value actually works pretty well through the process. So we got that in order. Let's go ahead and grab our text info. And we don't need a force update here because we just did that in prepare. But what we do need to do is we need to grab that color 32 array again. Cool, there we go. And now let's go ahead and loop until the whole process is completed. And I'm going to do something dangerous and just say while true, which means repeat forever, but it's not going to be dangerous because we'll break out of it manually. But let's go ahead and now iterate through our whole list, or actually what's within our range. So for int I equals minRange, let's start at the very beginning while I is less than max range. then I++. Okay. And let's do the same thing. Let's check if the character is invisible or not. Let's go ahead and grab the character info. And then if it's not visible, we're just going to skip it and move on to the next one. So let's grab the vertex index of this thing now, so we can have that starting point within the color array. And now we need to start moving the alpha of this character that we're on all the way up to 255. But the thing is, with bytes, they can't contain the decimal places like floats do, and therefore, if we're trying to lerp and we're trying to fade these things in, they're either going to get stuck or they're going to have to move too fast, because we will have to fade up by whole numbers. We can't do anything smaller than that with a byte. So instead of referencing the bytes directly from vertex colors, let's define ourselves a new float array that's called alphas, and it'll specifically hold the alpha values. And we're just going to set this to a new float, which is the size of textinfo.characterCount. So we've got an alpha for every character that we're rendering on screen. And this is just so instead of lerping and transitioning the alpha directly within colors, we're going to lerp and transition them within this float array and then apply that rounded to colors. So that way it keeps our bytes happy and we get the smooth fading that we want. So after we grab our vertex index, let's say alphas at the index of this character equals math.moveTowards, and we're going to start where we currently are. We're going to move up to the max value of 255, and we're going to do this by some sort of speed. So let's define that up here. Let's say our fade speed, float fade speed, is going to equal our characters per cycle. Just like we did with the typewriter up here. Where is it? Building typewriter. Where did I stick that? Right here. So this was our formula for getting the speed for the typewriter. So we'll do the same thing down here at the, where did I put it? There we go. We'll define the same thing here, but then let's go ahead and encapsulate these things. And we're going to multiply it by whatever our speed for the architect is, the overall speed. And also take every bit of that, and in order to get it to match up with typewriter, I found that I have to multiply this by 4 to get it to be pretty close to the same speed as typewriter. So that's our formula for fade speed, and now we will make sure that we use that in our interpolation. And that'll get and store our new alpha value for that character, so now it's time to apply it to the vertices of the character we're on. We'll go ahead and come back up here and snag this little line and paste it here. So we go through all the vertices, and we're going to set the alpha to equal the byte of alphas I. So we're applying that to every vertice, and then just one more check to see if we are now at max value, which would be 255. So if alphas I is greater than or equal to 255, then we know we're done, and we can say min range plus plus. We're going to increase it so that way this character now falls outside of the range. Once we're done with that whole for loop, once again, T and Pro, I'll just snag it from up here. Let's update the vertices, the colors on them all. And we've just got one more thing, and that's to increase our max range. So we want to do this after the last character that we're working on has reached that alpha threshold. So let's run a check here. But again, if our last character is invisible, then we're just going to need to skip it. So we need to check if it's visible or not. So let's check that. Let's make a boolean called last character is invisible and set that to equal if our textinfo.characterinfo for the last character that we're working on. If it's not visible, then we'll store that in the Boolean. And now let's check if the last character is either invisible or has exceeded the alpha threshold. If either of those cases is true, then we need to see if we can progress to the next character. If max range is less than text info dot character not info count, then we want to increase our range. Otherwise, if the alpha of our last character has exceeded or reached 255, which is max opaqueness, or it's invisible, then we want to break out of this and end the building coroutine. There we go. And now all we need to do is yield so all this doesn't try to happen at once. So while we're still inside of our while loop, let's just yield for the end of the frame. There we go. And that should allow us to fade text in. And so as we enter in Unity here, if we hit our space key, we can see that yes, indeed, our line is now fading in and looks pretty good. And if we hit the A key to append, our previously existing text stays there and we just fade in the new stuff. Very nice. And so there's one more thing that we need to do, and that's when we triple click, we force complete our typewriter, but we also need to force complete the fading coroutine as well. So let's come up to our force complete method, and all we need to do is say tmpro.forceMeshUpdate, and that's going to go ahead and force it to display all of the mesh. And with that, we can click and double click to make it go faster, or we can triple click to make it finish. And now the only other thing I can really think to add to this is we want to verify that if we happen to switch between the different display methods, that everything still works, everything still displays correctly and runs its logic appropriately. So we'll go into our testing script for that. Let's go into testing architect, and let's make ourselves a new button, or actually, let's go ahead and add an enumeration here. Public, and this will be the text architect.build method. That'll just be the BM, which is set to instant by default. So in our update function, let's go ahead and check if BM is not equal to architect.build method, then update the architect.build method to equal whatever we changed it to, and stop whatever it's working on. Actually, I want to have another key available to me to stop it, so input.getKeyDown and keycode.s, then I'll say architect.stop. That way we can stop the architect and move to a different build method and just make sure that everything works. So back in Unity, let's check out our testing script. And we've got the build method instant, so let's go ahead and start, make sure everything works. So we hit spacebar, and yep, it works, appending works. We might want to add some clipping there. But let's go ahead and change that to typewriter, hit space, and it works. Double click, triple, all works, appending works. So let's stop this in the middle, and go ahead and fade, which that works. And we've got the completions there. So let's stop fading in the middle and go back to typewriter and start that. Yep, appending works, and starting a new one works. Everything is working even as we're switching these build methods. So that's perfect, and you can do this for any other build method that you can think of. Those are the only three that I can really think of, so those are the only three that I've added in there. But if you come up with some other nifty ideas, just chuck them in there like we've done for these three, and you can expand that any way that you want. But that's it for this episode. We are all done with our text architect, so we can just throw that in a folder and move on to the next stuff that we're going to be doing. So next video is going to be all about opening dialog files, which we'll talk about what those are, but essentially we'll be able to get our speaker up on screen, or the name and the dialogue they're going to say, and just read all of it directly from a text file. So going to be some good stuff. Look forward to all of y'all joining me there, and until then, hope you have a wonderful week.